use two for loops. The first for loop increases the amplitude, and the second for loop increases the frequency. This allows us to see at what decibel level the patient can begin to hear the low and high frequencies at, and what level they can hear them best also. The t variable creates a time vector from 0 to 1 second with a sampling rate of 44,100. dB value creates a vector from 0 to 1 in increments of 0.1, and these will be used for our values for the amplitude. Our frequency variable is from 100 Hz to 10,000 Hz, and we use the line space function to create an array of frequency values, and the number of values is determined by the length of the amplitude variable. So our first for loop is created here. We create the amplitude variable and we let it equal to dB values. We display our current amplitude value, and then we enter a second for loop which changes the frequencies. So we start at 100 Hz, increments in 250 Hz all the way up to 10,000 Hz. X1 creates our sinusoid, so we multiply by our amplitude, and then this is our frequency variable and our time variable. We then sound this sinusoid at a sampling rate of 44,100. We pause for 2 seconds to let the patient differentiate between each tone that is sounded. We then plot this, and we plot against time and display our current frequency. It then exits this and enters the first for loop again, increases the dB value by 0.1 and displays our current amplitude, and then enters the second for loop again. So for the testing purposes, I'm going to make this quicker. So we can see our current amplitude was 0, our increments is 350 Hz, and so you can see here, once our amplitude actually is 0.1, it will actually make it sound. And we can see here, it starts at 100, increments by 250, and it goes all the way up to 10,000 Hz. So the ethical considerations for a test like this is the possibility of damage to the hearing, to the patient's hearing. If you're listening to loud noises for too long a period, this can damage your eardrum. So it is paramount to the patient that they stop the test if they experience any pain. We feel it was best to test a range of frequencies at a particular decibel level, as it is clear if a patient struggles to hear high or low frequencies at particular decibel levels. So if it is if the decibel level was at 0.1, they may not be able to hear those low frequencies, but they may be able to hear the high frequencies, or vice versa. And then if we increment this and it is at 0.5 and they're able to hear this low frequencies, then you can see this quite clearly using our code here.